we'll be using it. Okay. So recording is started. Good afternoon, everyone. I just wrote the formulae, the final two formulae, which were supposed to end trigonometry. They were sine of theta by 2 is equal to plus or minus 1 plus 1 minus cos theta by 2, and cos of theta by 2 is 1 plus or minus the root of 1 plus cos theta by 2. Now today, so that culminates trigonometry. Now we'll be starting with the concept of calculus. Now, calculus is basically a topic which is divided into two branches. You can say three, but I would prefer to say that the third one is a part of the first one. The first branch is differential calculus. The second is integral calculus. The third, if you want to consider it, is maxima and minima. But I consider it as a part of differential calculus. So we'll be starting with differential calculus first. So let us start. So for differential calculus, let me take a graph and let me say there are two quantities which I have. One quantity y and a quantity x. Now let me say that this curve is a curve which represents how the quantity y varies with x. It varies in such a way that you can see for every value of y, there is some value attached to it with x. But there is a catch over here. You cannot exactly predict if I tell you if, let's say, x is something, then what will be y? Why? Because it's not a line and you don't have an equation which can determine how you can get. It's a curve. So what we do is something called rate measurer, which measures the rate of. So for this, let me take 2 points on this curve.
Shaktam, you can take any two random points.
That won't matter much, but just for that purpose, you are doing it. Means, in a way, you can say that. Okay. So let me take any 2 points, A and B, where the coordinates of A are x comma y. So which means that from here, if I drop on perpendicular, then this length is y, as you know, and this length is x. Now, let me make some space over there. Let me say this point B has some other things. Now, B, the coordinates of B are x plus delta x, y plus delta. Let's say.
Shaktam, what is delta?
Delta means it's kind of a triangle and we use it in triangle, but mostly in physics, for example, that usually represents change. But I'm just representing it that it's just x plus something and y plus something for this one at least.
Okay.
Or it basically means change. So now, if point to coordinate geometry which we have learned, you know that this whole length is y plus delta y. Now, what my question is, let me pose it to, I think, no. Rajwal, am I audible?
Yeah.
Okay. So you know that the coordinates of B are x plus delta x and y plus delta y. B is over here. So if let's say I drop perpendiculars from B to x and y axes, assuming that they're perpendiculars, I know that this whole length will be x plus delta x. It's horizontal, and this is x axis, correct?
Yeah.
So this will be y plus delta y.
Okay. Yeah.
Now, you do know, let me make it a bit more easier. So from A, you know that this whole length is y, this whole length is x, right?
Okay. Yeah.
You know that B, this whole thing is y plus delta y, and this whole thing is x plus delta x. Fine.
Yes.
So if this whole thing is x plus delta x, this is x. What will be this place, this small place? The whole thing is x plus delta x,
Okay.
right? This place is x. So what will be the other part?
Uh,
Don't say I don't know. There's nothing which you don't know the answer.
I don't know exactly.
And x plus delta x is the whole thing. It's simple. Third grader will get this. If this whole thing is x plus delta x, this is x. What will be this part? This part. See, that is x. The whole thing is x plus delta x. I want to find this part. You already know that this is x. So what did I add to make it x plus delta x?
Yeah.
X plus what is x plus delta x? I'm asking.
I don't know.
Shreyansh? Shreyansh, you only answer.
Delta x?
Good. Not good, sir, right? Fine. So this is delta x, and similarly, this will be delta y. Now what I do is, let me join A and B. Okay, I'll use another chalk to make that visible. Okay. So let me join A and B. Now, one thing which you can make out additionally from what we had learned in trigonometry is, see, we had learned that if this is a line, and we know then it's how means change in its y coordinate divided by change of its x coordinate is its slope. But now let me take it this way. So change in y coordinate, change in x coordinate. We know that the quotient of those two is the slope. If I take this angle as theta, can't you also make out that the slope will be tan of theta? Perpendicular by base, right? This is, we change in y coordinate by change in x coordinate. So, yeah, it's self-explanatory. Perpendicular by base. Fine. Okay. Okay. Now let me join A and B over here, and let me make a triangle. Let me take this angle, this small angle as theta. You know that this is delta y, this is delta x. You can make out that tan theta is delta y plus by delta x. But hold on. That is true if you take that triangle. But the problem in this case is that the curve is also becoming steeper when you're moving between A and B. So this is not the precise definition of how the rate of what rate does y vary with x. What you do is simple. What you do in this case is you bring B so close to A that the distance between them tends to zero. But remember, very importantly, it can never ever be completely zero. Never. I can say 0.000000001, but and you will be like, chalo, take it as zero. That is not to be done. It will tend to zero, but it is not equal to zero. So I cannot represent that distance on the board, of course, but still I'll make another version of the curve. I'll draw a magnified version of what it is. Now instead of B, let me name the point. Let's say when you bring it, it becomes A prime. I'll draw the curve again. This is A. This is Y. This is X. Let me say I brought it this close. This is the new position of B, or you can take it as A prime. So when you bring it that close to B, aren't you making delta y and delta x attain such a value that they tend to zero, but they are not equal to zero? See, your Your objective is to make them come so close that what will happen exactly is, let me tell you, the slope of AB, which we took in the first case, the slope of AB, that will make an approach to the tangent of A. What is tangent, you'll ask? Then if I have any point and a line which is just moving, it moves. Okay, let me bring the point here. It just came in contact with that point and went. There's a line, there's a point. It just touches the point and goes. That is called the tangent to that point. So when you draw a line, for example, a line on the graph, and you take any 2 points, you know that the tangent to these lines is common. The tangent to these lines is common. And that is why you can figure out what will be the slope of this line, because it's a perfect line. You can easily figure out change in y coordinate by divide by change by x coordinate. But since this is a curve, you have no option but to make B so close to A that delta x is tending to 0 but is not equal to 0. Similarly, delta y is tending to 0 but is not equal to 0. So what will happen in that case is they will seem to form a line of their own. And in fact, as you know, I said the slope of AB makes an approach to the tangent at A. In fact, when you bring it that close, it will be like a line. And when you see a line, as I told you, you can easily figure out they'll have a common tangent. They'll have a common line from which you can determine its slope. So when I reduced delta y and delta x to values which tended to be 0 but are not equal to 0, I can write them as dy by dx. This is also referred to as a rate measure. So obviously, because it measures the rate with which a quantity y varies with the quantity x. So what I did is basically simple. Dy by dx, they are just values. They are just another way. It's not as if it's d into y or d into x. It's not like that at all. That is just what you say, other than writing that delta x is tending to 0 and delta y is tending to 0. So that by that way you can take delta y and delta x. Delta y and delta x have been reduced to those values which tend to 0 but are not zeros, and are represented as dy and dx, dy by dx. This is also referred to as rate measure. Okay? And everyone?
Shaktam, like, why did you write dy upon dx?
See, they were delta y and delta x, but when I'm reducing them to such values that they tend to 0 but are not equal to 0, that is a way of writing them. Dy by dx. Dy means very, very small change in x. So delta y and delta x means change in y or change in x. And dy by dx means a very minute change which tends to 0 but is not equal to 0. That is what dy and dx mean. Okay?
Okay.
That was for what is dy by dx. Now there are formulae. Not to be derived as such, but for example, some value like sin x and cos x, when you tell, like they can't be told in any other way. You can only say that is 1 minus sine square x by under root of that. But basically, sin x and cos x, they're kind of absolute values. You have to experimentally prove them. We don't have to do so by the grace of God, because many mathematicians have already done the work for us and have provided us with the formulae. What are those formulae? Now, you also must be remembering one other thing which I had informed you of when we were taking graphs, lines, and curves. is that y can always be written as a function of x, or mathematically f and then a bracket x. But what is dy by dx is nothing, but you can write it as f, this apostrophe we refer to as prime. So when I say f apostrophe, f single apostrophe means f prime. If I write double apostrophe, it means f double prime. So dy by dx is f prime x. This is also important. Please note this down. You'll be informed of the formulae in just some. Okay, so I think you have noted that down. Now let me inform you of the formulae. Let me make some space. First of all, I'll draw a table. So if this is y, then on this side there will be dy by x. First value. If y is equal to x raised to n, dy by dx is n into x raised to n minus 1. I'll be writing an example corresponding to each of them if they are required. For example, let's say you're given d of x square by dx, or to make it either understandable, dx by dx. So they have said x raised to n. What you do in this case is bring the n down. So first write 3, then write x, n minus 1, that is exponent by the way. Don't think it is n into x into n minus 1. No. It's n into n aside into x raised to n minus 1. So 3 is fine. 3 I brought down. Prajwal, are you there? Prajwal, can you hear me? Okay, fine. So n minus 1 will mean 3x raised to 3 minus 1, which will be 3x square. So that is what I meant when I said if y is equal to x raised to n, dy by dx is nx raised to n minus 1. So that was for the first formula. Now come when they are giving proper values. Let me write the formula. Sin x, cos x, there is sin x, there is cos x, tan x and cot x. When I tell you about the other rules, they can be proved, but for now you write them. We have tan x, we have cot x, sec x, cosec x, ln x. Ln x, let me tell you what that means. For example, let me tell you a fact. For example, you know that 10 cube is 1000. So there is something we write known as log, log, 10 down, 1000 up in the same line as log was is equal to 3. So it's like a kind of triangle. 10, move this way, raised to 3, move that way again, is equal to 1000. So similarly, ln x means there's a number e we refer to as exponential. Its value is approximately 2.72. So
Shaktam,
yeah,
Shaktam, I didn't understand one thing. Like in the table, in the left part of the table, like you have written cos x and everything, like tan x, cot x, sec x.
Ah,
Like, why have you written these?
because I'll write dy by dx later. I'm just writing them down for you.
Okay.
So, what do I mean by ln x is log e down x. So that is what I mean. And log e, whenever they give, you can write as ln x. Okay. And since you know that what we are doing is y is equal to x raised to n, y is equal to sine x. So what we are doing in this case is basically ln x is equal to 1. Now, that was what is logarithms. We have ln x.
How do we use logs in calculus?
Calculus, you will just be given numbers, for example, like e raised to x. E raised to x also I'm telling. We have just two more left. Means log you can use in calculus as in, for example, they can give you ln of 3x square and then you can find it out. We'll see the examples and then we'll get to it. Ln x, 1 by x, and finally e raised to x. Now the values. d of sine x by dx is cos x minus sine x tan x sec square x cot x minus cos x square x.
How are you getting these values?
Those are formulations.
So, do we have to remember them?
Yes. You do.
Okay, so the this table will be used in every calculus sums.
No, means not in everyone, of course. Means, for example, they'll be like d by dx of sine x. Then you just say it's cos x. But this table has to be in mind. What is the value of that?
Okay.
See, there are a few more formulae like sec x you have, cosec x you have, tan x, cot x. This place, these four can be proved by the other formulae which I'll tell you. So sec x, this will be sec x tan x. Cosec x will be minus cosec x cot x. Ln x is 1 by x. Okay, there's no 1 by x over here. There's only one more ex e raised to x. E raised to x is e raised to x. Okay, now let me take the examples, but only after we learn the certain rules for finding the derivatives of the of some other functions. Can you see the whole board? Just a minute. Note this down or take a screenshot, whatever. Some parts may not be legible. Let me write them. This is x, not n. So take that as x. Okay, done. Note it down. I think all of you are done with the noting down of these. So let me tell you the other formulae. Okay, so the other formulae are as such. D by dx of c into y is equal to c dy by dx. This is only if c is a constant. First formula, next. D by dx of u plus v, where u and v are just functions of x. U plus v is du by dx plus dv by dx. Next, d by dx of u into v. Anyone said something? U dv by dx, u out, plus v du by dx. Then we have d by dx of u divided by v. D by dx of u divided by v is v du by dx minus u dv by dx whole upon v square. Finally, the last formula, which is in fact the most important, you can say, that is used in many a case. Dy by dx is equal to dy by du into du by dx. So note down these formulae and then we'll see how they are applied.
Shaktam, can you do something because the board is very light? It's not sufficient to see.
Now,
No.
better.
Yeah, better.
Done? Done, everyone? All of you are done with the tables? Anyone, can you reply? I think. Is my network fine?
Done.
Okay. Others done? Prajwal, Ryansh, Shreyansh, all of you done?
Yes, Shaktam.
Okay. So with these, with this table and with these formulae, we can almost of all the functions determine the derivatives. So let's have a few examples for the same before proceeding to the next topic. Okay. I'll give you 3 examples. First one is with the first rule. One more thing. Okay, let me correct my orientation. Also, that if we know the differentiation of a constant is 0, you can't differentiate a constant. Okay. Now, for example, if I say d6, d of 6 by dx is 0 because 6 is a constant. Next, find the value of d of root x by dx. Now, you can recall exponents and powers, what we had learned, that root x is nothing but x raised to 1 by 2. And from the first formula in the table which I had drawn, you can see that this will be half of x raised to 1 n minus 1, half of half minus 1, which is minus half. So this is half into 1 by x raised to 1 by 2, as you know, and x raised to 1 by 2 also can be expressed as root x. So 1 by 2 root x. That is the example for this. Then we have, for example, let's say if let's say it's something like d of x square plus x by dx. I'll give this to all of you. Can anyone tell how you go about this? Shreyansh. Yeah, Shreyansh.
Yes, Shaktam.
So how will you start with this? From the formula which we have learned, which one will you apply? D by dx of u plus v is what? Go to the page where you noted them down.
Yes.
What is the value of d by dx in d? How does u plus v vary with dx? D of u plus v by dx. You wrote down, right? Du by dx.
It is
Continue.
dy upon dx plus dy upon dx.
No, it was u plus v. So it should be du by dx plus dv by dx. Not y
Oh.
by.
Okay.
Make that change. It's du by dx plus dv by dx. So here also simply you do dx square by dx plus dx by dx. Dx square by dx will be 2. 2 into x raised to 2 minus 1 is x. X raised to 1, which is x. And dx by dx is 1. So 2x plus. So that was for this one. Next, when we have learned about the product of u and v. So let me take the example. D by dx of x square sine x. D by dx of x square sine x. That will also be simple. It will be v du by dx plus u dv by dx. So x square into d of sine x by dx plus sine x into d of x square by dx. Now d by dx of sine x is cos x. So first part will be x square cos x. Second part will be sine x into 2x. So sine x into 2x. So x square cos x plus 2x sine x. Now for the quotient rule, if you want to find the d by dx of u divided by v. So that will be, for example, let me give the example. See, that what I was telling at that time about the 4 ones, the tan x, cot x, sec x, cosec x, you can prove them with that rule only. For example, take what we had learned for cosec x. D by dx of cosec x. Cosec x is nothing but 1 by sine x. Now, before that, well, we had learned that d by dx of cosec x is minus of cosec x cot x. So let us see how we came about. So d by dx of 1 by sine x. And from the quotient rule, you are aware of the fact that this can also be expressed in this form. Sine x into d1 by dx, right? V divided by u, so that's how you. If u divided by v, So the denominator first, d by dx of u by v. Then what you do is, denominator you first bring up sin x into d of 1 by dx. And then you do minus 1 into d of sin x by dx. All divided by sin squares. d1 by dx you know is 0. Now, minus 1 into d of sin x by dx. That you know is, anyone, d of sin x by dx? You noted it down, right? What is dy by dx if y is equal to sin x?
Cos x.
Cos x, exactly. So 0 minus cos x by sin square x. Now, minus of cosec x cot x will be nothing but minus of 1 by sin x into cos x by sin x, which is minus of cos x by sin square x. Fine? Fine all? Supposing that this you got, let's move on to the final one, the chain rule, the very important one. Okay. So the question is a very, you can say that it is intriguing. If y is equal to ax plus b, the whole cube, find, as usual, you have it. Now, what you know is dy by dx is dy by du du by dx. Now, let me say that ax plus b, let's say, see, it's simple. dy by du into du by dx. Cancel du and du. So you'll get the same thing. I'm not changing the dynamics of the equation in any way. Now, what you do in this case is, let's say ax plus b is equal to u. Then you know that y is equal to u. That is dy by dx will be 3 into ax plus b, the whole square. Fine? Because it will be 3u square and u we know is ax plus b. Now, just a minute. What did I say? Dy by du, sorry. Dy by du. Now what they're asking is, now let me say du by dx. Du by dx, the d of ax plus b divided by dx. So that will be a. B is a constant. Okay, a and b are constants. So it will be d of ax by dx plus db by dx. D of ax by dx will be a. Okay, one more thing is, I told, if it's a constant, d by dx of c into y, where c is a constant, then it is c into dy by dx. So that will be d by dx of ax will be a into dx by dx, and dx by dx is 1. Similarly, db by dx, b is a constant, that will be 0. Now, du by dx, du, dy by du and du by dx. So, dy by du into du by dx. So, will be same. So, dy by du into du by dx will be 3 into ax plus b the whole square into a. 3a into ax plus b the square. Okay. Fine, everyone? Okay, taking that you are fine, let's move on. What is the time? Anyone tell me the time?
150.
150. Okay. Okay, so we'll move on to maxima and minima, which I consider as a part of differential calculus. So, one more thing is that if I know dy by dx, then d of dy by dx is written as d2y by dx square. Mathematically, what it is the rate of change of slope with x. You can say dy by dx, as you know, was the rate of change of y with x, which is the slope. But this is the rate of change of slope with x. d2y by dx square is the rate of change of the slope with x. Now what I do is, let me take another curve. Okay. So from here you can deduce that at this point, what if y and x are the quantities, then at this point it is maximum. This point is a minimum. I repeat. If a quantity y depends on another quantity x in a manner as shown in this figure, then you can see that it is maximum at this point, minimum at this. Now what I do is, let me extend this x-axis a little. Let me do now. What you can see is, let's draw tangent. The tangent to this point will be this. Now, what I want you to do is, just before it becomes maximum, and just after it becomes maximum. Similarly, just before it becomes minimum, just after it becomes minimum. Note the slopes. Means note them down at a point just before and just after maximum, just before and just after minimum. So, let me draw tangent. And then, okay. Now what you can observe is, just before the maximum, this angle is acute, slope is positive. This angle is obtuse, slope is negative. So what you are observing is, what I am trying to do is make a use of d2y by dx. Similarly, if you observe over here, mind you, not similarly, but similarly. What I mean by that, let's see. If this angle, as you can see, is obtuse, and this angle you can see is acute, i.e. negative and then positive. In fact, and this also should be 0. So what you're observing is, it's positive, it becomes 0, then it goes negative for a maximum. When it's minimum, negative, 0, positive. So what you're observing is, the rate of change of slope near a maximum is negative or positive, because it's moving from positive to 0 to x. Shreyansh, are you there?
Yes, Shaktam.
If something is moving from positive to 0 to x, what is happening to it? Increasing, decreasing?
Increasing.
Positive to 0 to negative.
Decreasing.
That means, now you can see, at a maximum, isn't dy by dx 0? Because slope of such a line is 0. You know that, right? Why? Because y is unchanged. See, we had learned in graph science and curves that when I have a change of y coordinate and change it divided by change of x coordinate is what is slope. If it's a constant one like this, if it's parallel to the x-axis, y is not changing, right? Only x is changing, which means it's 0 divided by change in x, which means dy by dx is 0, not only at a maximum, also at a minimum. Getting me? See, basically, I told you when we were taking that quiz, horizontal lines, if it's parallel to the x-axis, slope is 0. Remember. Okay? Now, at a maximum, dy by dx is equal to 0. d2y by dx squared is lesser than 0 or is negative. Lesser than 0 or is negative because positive to 0 to negative. So it's decreasing. The slope is decreasing as you move at a maximum. This is for maximum. At a minimum, dy by dx is again 0. But d2y by dx squared is increasing. This means it's more than 0. So this is what you can observe, or you can simply remember this. dy by dx is 0 at maximum and minimum. This you can remember easily. But at max, it is negative. d2y by dx square is negative. At min, d2y by dx square is positive. Fine? So those are the conditions of what happens at a maximum, what happens at a minimum. So let's say I have a question which is as follows. So you want to note this down, note it down. I'm giving you till 58 to note it down. After that, I'll give a question and then a little bit more information to conclude the class.
Shaktam, will we have a quiz today?
Yes, we'll have a quiz today. Done? Noted it down? Okay, I think you guys have noted it down. So let me give you a question. The height reached in a time t. The height reached in a time t by a particle thrown with speed u is given by the equation h is equal to ut minus half gt square is given by the equation h is equal to ut minus half gt square, where g is equal to 9.8 meter per second square. Where g is equal to 9.8 meter per second square and is taken to be a constant. Determine the time taken for the particle to reach the maximum height. Solve this by 201. It's not that much difficult. And and then tell me the answer you get. For 20 seconds to go. And time's up. Okay. Shreyansh, do you have the answer?
Shaktam, I got stuck with this question. Can you help me in this? I'm not clear with this.
Okay, fine. So basically, it's not that much difficult. H is equal to ut minus half dt square. That is the time taken to reach the maximum height. So figure out what is dh by dt. What is dh by dt? You must have got to some point. Can you tell?
Yes.
What is dh by dt?
dh by dt is dh upon dt plus dh upon dt. Is it this?
No, it will be nice. See, you know that, for example, h is a function in time where is equal to ut minus half dt square. Now you learned that d by dx of u plus v is du by dx plus dv by dx, right?
Yes.
So d of ut by dt, u is constant because if I throw it with some velocity, that velocity is a constant value. I just threw it and it's done.
How did you get dh upon dt here? Can you tell me?
That is what I'm going. So we know the d by dx of u plus v is du by dx plus dv by dx. So this case will be u. U is a constant. So I'm getting u out for the first term. Looking at ut. U into dt by dt and
Yes.
because u is constant. See, you're actually finding out. Basically, let me see what this is. D of ut by dt minus of d by dt of half of dt square. Now, d of ut by dt. U, you know, is constant. I can bring u out. It's similar to d of cy by dx, which will be cdy by dx. In this case, the constant is u. I'll bring u out. And then I'll get d of whatever is left inside the bracket. So d of e by dt. Similarly, minus g, I told you take it as constant. So minus of g by 2 into d by dt of t square. dt by dt is 1. So u minus g by 2 into 2t. Fine? Finally here?
Shaktam, like there's one doubt in the starting also in this.
What is it?
Like, how did you start with this formula? This formula isn't written there.
dy by dx is just, it's showing y, how is y varying with x. So that will mean, in this I'm just taking h with time. So just replace the y and all with y and x with t and h and t respectively. So it
Okay.
will be d of ut by tt and d of cy by dx, you know, c dy by dx, where c
Yes.
is a constant, right?
Yes.
U I took out in the first part. Got that one?
Okay.
And d of ut by dt. Now, see, the value which you had got last time was, when in the formula, d by dx of cy is equal to c outside the bracket into whatever is left inside the bracket after I get C out into dy by dx. So similarly, if you look over here, I brought u out. I have dt remaining, d of t. Fine.
Fine.
So u of dt by dt for the first
Okay.
part. Now, what you'll do is similarly, g 1 by 2 is a constant, right?
Yes.
The question says that g is to be taken a constant.
Yes.
So minus of means half g is also a constant.
Yes.
So take half g out. So you get minus of g by 2. And similarly, what you had done last time, d by dt of t square. See, basically a function is when we are uh, finding the derivative of a function, what our main aim is to get only the function of, means if I'm doing d by dt, it should be only something with t square. All the constant and all, they should be separated. That is my aim. Only a function, an exact function, if t square, which you can find with the formulae, I should be left with that much. That is my aim. Got it?
Yes.
Now, d by dt of t square, you bring the 2 down and it's 2t raised to 1, which is 2t. Fine?
Yes.
So you're getting dt by dt is 1.
Yes.
Fine. So u for the first part minus g by 2 I have kept unchanged. It's a constant. D by dt of t square, as you said, is 2t. Okay, that is not, that part visible.
Yes. It's totally visible.
So finally it will be u minus gt. Correct?
Okay.
So this is for dh by dt. Now, what they're asking is maximum height. What is dh by dt at a maximum? Not d2h by dt square, dh by dt. Okay, dy by dx, what I told you, dy by dx at a maximum is what? 0.
Yes.
And d2y by dx square, you leave d2y by dx square for now. But dy by dx is 0 at a maximum. So I figured out what is dh by dt in this case. Simply equate u minus dt to 0. You need to find the time taken to reach the maximum height. At maximum height, dh by dt will be 0. So if u minus dt is dh by dt, it's to 0. Fine.
Fine.
What they're asking is time taken to reach maximum height. U is equal to gt, t is equal to u by g. Got it now?
Yes.
That's it. Time taken to reach the maximum height.
So we can leave the answer like this only?
T of u by g. You don't know u and g, so you can perfectly leave it like that. Got it
Okay.
now?
Yes. 1 second, I'm just doing it in the notebook.
Okay.
The last part. Done chapter.
Okay. So before the quiz, just the final one. How we use. Like if I have a circle like this, and let's say these are the diameters, and these are all radii. So you can in a way take it as XY graph paper. So if I take it somewhat like this, what you do is, it's actually simple. It's not quite complicated what you do. In the first quadrant means this one. This. In the first quadrant, dy by dx, dy by dx is negative, and d2y by dx square is also negative. Now let me explain after this how we can use this information, because this is very important, all this information. Secondly, This is for the first quadrant. Let's say these are R1, R2, R3, and R4. In R1, dy by dx and d2y by dx square are both negative. Secondly, in the second quadrant, dy by dx is positive, d2y by dx square still negative. Then dy by dx this was for the second one. Now for the third one. For the third one, dy by dx is negative, d2y by dx square, that is positive. And in the fourth and final quadrant, dy by dx is positive, d2y by dx square is also positive. Basically, remember it like this. Both are negative in the first one. First one becomes positive in the second one. Then what happens? It becomes minus plus. And then it becomes plus plus. Minus minus plus minus minus plus plus plus. Remember it like this. Now, how you use this information is also important. So this you can note down. So let me give an example how you use this. Now dy by dx, let me tell you one thing. If there is if we have finding a relation between velocity and acceleration of a body, for example, what we do is dv by dt, where v is its velocity, that is equal to its acceleration. dv by dt is its acceleration. And yeah, that is, and you also should know that ds by dt, where s is the displacement, that is equal to v. So basically, from here you can deduce that a is actually also d2s by dt square. Why? Because it's d by dt of ds by dt. Now, what the question is, with which you can use this whole circle information, is if I have such a graph, which represents the variation of acceleration of a body with time, convert this into a graph which will represent how the velocity of this body varies with time. So the answer for this is simple. Now, we can take this into two parts. One where it's all in the positive region and one when it goes negative. So, in the first part, in this part, what we can see over here is dv by dt is lesser than 0. Why? Because it's going down, right? And acceleration at a certain point, slowly going down. If it's going down like this, it means it's going negative. So a, which is dv by dt, is negative. Now, then what is happening is d2v. Okay, wait a minute. Sorry, I'm just sorry, just a minute. Although it is like this, it is going down. Acceleration is still positive, so it's what am I? Yes, I was right. My symbols were right. I was speaking wrong. dv by dt is greater than 0. Acceleration is positive in this first part. But what is exactly negative when you see that it is going down is actually, isn't it the slope which is dA by dt? A you know is dV by dt. So that will be d2v by dt square. That you can say is negative. That I am not having any concept. Now, make a relation with this chart. So we have to find a case in which one is positive and the other case is negative. Where is that case? That case is in the second quadrant. How does that have any merit? Simple. This curve you have over here, what you do is, they're not given any limits at in what time and what. So we're just going to assume, put that curve here. That is its use. Put that curve as if you are extracting it and put it over here. Now, in the second part, this still remains negative. d2v by dt square still remains negative. But now acceleration goes negative, which means even dv by dt goes lesser than 0. This you can see is negative, 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 negative is the first quadrant. What I do is take a point where slope is 0, transplant this thing here. That is the very important use. In fact, this question only, although it was MCQs, was asked in IIT-JEE. It's that important. And no institution has taught how with a circle we can transplant the curves and put it up. So this is the use of all this. If it's fine with everyone, which I believe it is, I'll start with the quiz. Any doubts? Anybody? No doubts?
No, Shaktam.
Okay, then let us start with the quiz. It's a very easy quiz. You will not have any problems. It's basically just keep that formulae sheet handy. I'm sending the link of the quiz. A few minutes. It's hanging a little bit. Bear with me. Okay. Take this link and join the quiz. All the best to everyone. Okay, one person has joined. What I've observed in all cases is a war between Ajinkya and Shreyansh, in which always Ajinkya is the winner. Only when it comes to speed, means what happens usually is the case is that accuracy of Shreyansh is more, but going to speed, he becomes second. And in one quiz, they were tied on their accuracy. But since this is not exactly an exam, this is a quiz, both of the categories of speed and accuracy merit. Shreyansh, chance to get yourself that first place. So let it go. Are there only 3 people? Shreyansh, Ajinkya, and Shreyansh. Yes. Very less attendance today.
Shaktam,
Yes, Neeraj.
What do we have to do in questions like differentiate?
Just a minute. Yeah, what were you saying?
what do we have to do in these questions like differentiate y is equal to 12x to the power minus 2?
Select the option.
Okay.
When I stop the quiz, I think everybody is done. Stop the quiz now. Yeah, your two accounts, you're already done from one account. Why will you Can I stop the quiz?
Yes, sir, you can stop the quiz.
Yeah, you are there. You're already done. Third is Shreyansh. Third is Shreyansh. Second is Ajinkya. First is Reyansh. Okay. Toughest question and longest question. Toughest question. 5 out of 6 players answered incorrect. What is in this question? Who has an iPhone, man? Okay, what's so difficult in this question, man? Like, see, you bring the 3 down. So 1 by 3 into 3 is 1. X cube, nx minus, nxn minus 1, right? So x cube will become 3x square. And then you're multiplying 1 by 3 to it. That'll become x square. Similarly, 1 by 2 into x square. That'll become 1 by 2 into 2 into x, which will be x. X square plus x. This was easy. This was for the toughest question. Longest question is which question? X into 2x minus 1 into 3x plus 1. What you could have done in this one is, see, x into 2x minus 1 into 3x plus 1. So take x into 2x minus 1 as one unit and 3x plus 1 as the other unit. So what you have learned is what you have learned is d by dx of u into v is v du by dx plus u dv by dx. So in this case, I'm taking this part first. So then 2x minus 1 into dx by dx plus x into d of 2x minus 1 by dx. So that will be dx by dx will be 1. So 2x minus 1 plus now x into, how does 2x minus 1 vary with x is also a simple thing only. It will be 2 because minus 1 is a constant. So plus of 2 into x. So this will be 4x minus 1. Then differentiation of 3x plus 1, right, by dx is equal to 3. What they're asking is multiplication. So you got this one as 4x minus 1. So you'll do 4x minus 1 into d3 by dx plus 3 into d of 4x minus 1 by dx. Wait, this term will be 0, I'm getting that, because 3 is a constant. But 3 into d of 4x minus 1 by dx. d of 4x minus 1 by dx, that will be 4. So it should be accordingly 12. The answer should be 12. Or what they actually wanted in this question is, I think what they wanted is, you should multiply all the terms first. So you'll get 2x square minus x into 3x plus 1. Finally do that, and then you figure out only the differentiation. Fine. So that was it for this one. And by the way, you guys also, okay, my mistake, not your guys' mistake, not your mistake. There were a few more formulae I wanted you to note down for d by dx. Note them down now only, because one question required them and I forgot to tell you them. Pardon me. D by dx of sine inverse x is 1 by the root of 1 minus x square. D by dx of cos inverse x is minus 1, the same denominator, d by dx of tan inverse x, d by dx of tan inverse x is 1 by 1 plus x square, 1 plus x square. Then d by dx of cot inverse x, d by dx of cot inverse x is minus 1 by 1 plus x square. Then d by dx of cosec inverse x is. Now let me write down the formulae, and then there'll be one part which you'll be confused with. I'll tell you what that means. D by dx of cosec inverse x is 1 divided by mod of x under the root x square minus 1. And finally d by dx of what's left, sec inverse x. That will be, oh wait, sorry. This should be sec inverse. This should be cosec inverse. And cosec inverse will be this time minus 1 by x raised to x square minus 1. Okay. Now x in these vertical brackets means that x, just the value of x, the absolute value of x, irrespective of whether it is actually in the question positive or negative. So for example, if they are asking sec inverse minus 2, you'll write in the denominator 2 into root of x square minus 1. Accordingly, you'll figure it out. And so those were the other formulae. So that's it. We'll meet tomorrow, where we'll discuss integral calculus, which will not require much time, by the way. And then we'll also start with vectors tomorrow. Fine?
Excuse me, sir.
Yeah, Ranch.
Sir, on Monday is our test, right?
No, there's no test on Monday. The test is on the 5th of July.
Okay,
That'll be the
sir.
final time we'll be meeting.
But in the test list, you wrote that there's a test in.
I wrote
Yes,
three
sir.
tests, but I wrote 3 tests, I know. But there has been a bit of change in the plans. So there'll be only 2 tests. The one which you are taking the first time, and the other one which you will be taking on the 5th of July, which will be last time we'll meet. Okay?
And when will you declare the results?
Not gonna declare the results. Only if you get the certificate, you'll see if you were the one who got 97.5% and above. By the way, one information. Nobody got what I expected in the first test. Okay? That's all I can tell. I'm not going to tell the marks or anything, because marks are those kind of numbers which usually just put pressure on you and just put you in a bad state. I'm not going to tell you marks. I'm just going to tell you, if you got 97.5% in the second test, which will be on the 5th of July, then you are sure to get a certificate. Okay? Okay then. Bye everyone.
Bye, sir.
Bye, Shaktam.
Bye Shansh.